All right, good morning, everybody. So for today, we're going to be doing the classwork Unit 2 final review. Again, as we prepare ourselves for the final next week, here's the we do, you do problems that we're going to be doing for today. They're a little bit mixed, but that's okay. You should be able to figure out which ones you are going to try. So you should be on page 11. Here we go. For question number 1, it says solve for x. And if you notice, we only have one x involved. Yes, it's a quadratic, but when we only have one x involved, that means we're going to move everything away from it. So if I see a -7, then I'll add a 7 to both sides. So we end up with 4 parentheses x minus 3 squared is equal to 100. Then, of course, we still can't get rid of that power of 2. We need to get rid of every other value around it first. So that 4 in front should get divided here. So we divide everybody by 4. And if you notice, I end up with x minus 3 squared. 100 divided by 4 is 25. And now we can concern ourselves with that power of 2. And the only way to get rid of a power of 2 is to bring in a square root. So we will square root both sides. But you have to remember one thing. Since we are dealing with the quadratic, that means we're going to have two possible answers. So yes, on this side, the power of 2 and the square root cancel each other out. But when you take the square root of 25, for many of us, we'll say the answer is 5, but we need two answers, which is why we're supposed to be giving it a plus or minus, a positive and negative result, which is why this is when we split it up. We go x minus 3 is equal to positive 5, and then we go x minus 3 is equal to negative 5. That's how we're going to get our two solutions out of this problem. So I'm going to add a 3 to both sides as always. We'll add a 3 here as well. Might as well get both of them ready. But look at the two different answers we get. X is equal to 8, right? 5 plus 3. And then negative 5 plus 3 is x is equal to negative 2. And these are the two solutions, right? They end up being the x-intercepts of this quadratic function. Remember, when we were solving, even when we were doing it with square roots, it only works if you only have one x given a power of 2. So obviously you'll try the one, number 2 right below, but we're going to do this entire page first. So here comes number 3. Once again, looking at it carefully, I notice that it has a power of 2. So we know it's a parabola, right? It's a quadratic. But the other thing that stands out to me is the fact that it's a negative value. So because we have a negative value, we know that this is the type of parabola that's going to open down. So if your test is multiple choice, we're going to be looking for these. The one thing we need to remember when we're drawing a quadratic, especially with the multiple choice test, it's let's talk vertex. The vertex is probably the most important point of a parabola or a quadratic. And when we have it in vertex form, then it's very easy to spot our vertex. See, I need an x value. Well, then let's go to where the x is located. And as soon as it says x plus 3, then my vertex starts off with a negative 3. We always think opposite. But then when I see the plus 2, no opposite talk on this one. We get our vertex of negative 3, comma 2. So we're going to draw this point. We're going to go to negative 3 and positive 2. So there is our vertex. And we already know we're dealing with a parabola that opens down. And because we're not doing any kind of stretching or shrinking, then we already know that our classic 2 points kind of form this little T, if you think of it that way. And just like that, we have our parabola, which, by the way, it should be enough on a multiple choice test to help you figure out what the solution should be. Simply knowing where the vertex is and knowing that it opens down should be enough information to help you find the answer on a multiple choice test question. Now, moving on. Again, the you try is number 4, so you're basically doing all the evens. So here we go. Number 5. This one says describe the range. Now remember, when we're talking about range, we're thinking y-axis. We're going to think about the y-axis. But in order for me to do this problem, I can look at my problem here. It says f of x is equal to 2x squared plus 5. Notice how I put the x, because that's the only thing that has a power of 2 in there. Reason I did that is I'm going to look at my vertex. See, my vertex for this problem, look at the x value. There's nothing adding or subtracting on the inside. And if there's nothing adding or subtracting on the inside, then we start off with a 0. And then when it says plus 5, we know our y value should be a 5 out here. So just like that, we have a vertex. This is a positive, so we're dealing with a parabola that opens up. And yes, we have a little bit of a vertical stretch, but let me show you how we handle that. When we do a vertex of 0, 5, then I go up 5. There's my vertex, 0, 5. We know we're dealing with the happy parabola, right? It opens up. And so we know it's doing this. We're not going to worry too much about the stretching, especially since I don't have any points to work with. But now here comes the concept of range. The range is you got to think y-axis. So I'm looking at my y-axis. And if you think about it, this is the lowest y value that this graph gets. This y value is 5. But then my graph exists everywhere above that 5. And so if my graph exists everywhere above it, but there's no graph below, that is why we say that the range is only when my y's are greater or equal to, because I do make contact there, to the number 5. So your max and your min are actually going to help you out with the range as well. We don't tend to think of it too often that way, but your max and your min kind of determine what where your range begins and ends or starts, right? So range, again, you have a problem just like it at the bottom here. You'll do a quick little graph, and then you're really just looking at, okay, well, this is my lowest y value. Then my answers have to be greater or equal to 5. If I had a parabola that opened down, it would have said y is less than or equal to 5. I would have still used that 5. All right, so we're going to pause the video for a moment, take some time to work on the even numbers on this page, 2, 4, and 6. So try them out, check your answers with the key, and then we'll continue with the rest shortly. All right, you've had a chance to work on 2, 4, and 6. So let's flip the page and work on the try these on the other side here, or the we do's. So the next topic is the concept of vertex. Remember, the vertex is probably the most important point in a parabola. We usually call it h and k, but we can also just call it x and y, of course. And the reason we bring this up is that in order to find the vertex, we actually have a little formula that we're able to use. To find the x, we use this formula here. Now remember, this is assuming that the equation is in standard form. That's why we're going to show you an example right below with that. And then to find the y values, all I have to do is plug in the x so that I find the y value that goes with it. So let me show you what I mean. This equation here, look at that negative. So we already know it's one of the parabolas that opens down. Doesn't matter too much, at least for this question. But we already see that in this case, this is what we call standard form, which is why what it says up here, we'll be able to use it. So they said, give me the vertex. All right, well, I need an x value first. To find the x value, it says negative b over 2a. So notice, when you set it up, you should have 2 empty parentheses, but it says negative b. Well, my b value is what's next to the x, not the x itself, but whatever's next to it. So it's a negative 4, so then I'm going to put a negative 4 in here. And then it says, well, tell me what the a value is. Well, the a value is whatever's in front of the x squared. And in this case, it's just a negative. But of course, it'd be weird to just write a negative sign. So we're going to write in a negative 1. Now we can let Desmos help us. We can do whatever we need to. We end up with a positive 4. 2 times negative 1 is negative 2 for a grand total of negative 2. There's the x value. So when I'm doing my vertex, right, if I'm getting this thing ready, here's what I have so far. I already know that I have a negative 2 as a result. So now it says, well, I need a y value that goes with it. Well, according to the little note that we wrote, in order for us to find a y value, all I have to do is plug back into this equation. I know it says f of x. I'm just going to call it y for short. And it equals negative. I see an x. I'm going to put a parentheses, squared, minus 4. But I see an x, so I put a parentheses, minus 3. And the number that we said that we needed to plug in here was that negative 2 that we found earlier. And this is definitely a problem that you want to let Desmos pretty much do for you. You just type this whole thing in, except for the letter y, of course. And so when you do that, according to Desmos, we get y is equal to, yeah, after all of that, I think the answer is just a 1 on Desmos. And so just like that, we have our answer for our vertex. So we don't need to graph. We don't need to do completing the square. We just need this little formula. That's what's going to help us find our vertex. So you'll do the same thing on number 9. Now let me show you number 10 and number 11 as well. So with number 10, so you see, you'll find the vertex like you did up here. All right, number 10. It says find the x-intercepts of the graph. Notice this one says find the zeros for number 11. Don't forget, an x-intercept and a 0 are the exact same thing. So all I have to do is take the same approach for both. Now, we have two options. Option number 1, I can factor. Option number 2, I can use the quadratic formula. Same thing on this one. It says find me the zeros. Option 1 is to factor. Option 2 is the quadratic formula. Go with the one you feel more comfortable with. So I'm going to try the factoring. So I'm going to factor first. All right. When it comes to our factoring, let's see. I set it equal to 0 because I am going to be looking for x-intercepts, but I need to factor this one out. Now remember, this is where we have to use the guess and check technique for this one, especially because we have a 2 here. So the only factors that give me a 2 are 2 and 1. So it's 2x and x. And then the only factors that give me a 7 are 7 and 1. And we know it's a negative. The issue is that when I put these numbers in, right, I could try one set first. Let's see. What if I said 7 and 1? That's how I get a 7 right there. We know one of them is a negative. 7 times x, 2x times 1, that's 7x. That's 2x, but I'm trying to get a 5x out of it, which means the 2x should be the negative. There's the 2x, make it a negative, which makes the 7 a positive number. There, everything checks out. We'll make it nice and dark here now, since we don't have to erase. All right, my factoring is done. So factor first. Now I'm going to set equal to 0. So I'm going to take every factor I have here and set it equal to 0. 2x plus 7 equals 0. X minus 1 is equal to 0. All right, let's do a little solving here. Subtract the 7. 2x is equal to negative 7. Divide by 2. And even though it's a fraction, that's okay. My first x-intercept is negative 7 over 2. So we got our first one. The next one isn't as difficult. All I'm going to do is add a 1 to both sides. And so we get an answer that x is equal to 1. Just like that, using our factoring, we found the 2 zeros, aka x-intercepts of this graph. Even though we're not graphing, technically that's what we're finding. All right, and number 11. We said it's the same thing. If you're going to find zeros, then I'm going to set this equal to 0. And it's x squared plus 3x minus 28. Well, I'm going to factor. And I forgot to say we set it equal to 0. And then we just solve. Okay, there's the 0. Well, now I need to factor this. Now, this one's a little bit easier. We can see that the two numbers that multiply to give me a negative 28, and then I need two numbers that combine to give me a 3. We know one's a positive and one's a negative. So let's see, 28. That's 7 times 4, but I want a positive. So it's positive 7, negative 4. Positive 7, negative 4. So I have x plus 7 See, they make that positive 3 and x minus 4. Well, just like before, look, I factored. That's done. I'm going to set them equal to 0. So x plus 7 is equal to 0. X minus 4 is equal to 0. Subtract the 7, add a 4. So then I end up with x is equal to negative 7. First solution, first x-intercept, and x is equal to 4. And just like that, we have 2 of our answers for this problem. All right. Now, you're trying numbers 12 and number 13. The only other thing left on this page for now is called the quadratic formula. Here's the formula. It's also in your word wall. But don't forget, when we did this, we also talked about it as discriminant. See, the 3 is your A, the 5 is your B, the negative 3 is your C. So when we did this in class, we said, let's talk about the discriminant first. So we end up putting the 5 in a parenthesis squared. The A is a 3. The C is a negative 3. We let Desmos handle all this work for us. And according to Desmos, all of this actually ends up being a negative 11. So we have to remember what this tells us. When we end up with a negative 11, it means we're going to have 2 imaginary. We're going to have 2 answers that are imaginary. And then what we normally did right after this was we finished the quadratic formula, where it says x is equal to negative b plus or minus, but now I'm just going to put the discriminant over 2a. So here's my b value 5, my discriminant was negative 11, and my a value was a 3. So now I'm just going to do whatever I can. We end up with a negative 5 plus or minus. When you have a negative in here, though, it means there was an imaginary number, and I can't take the square root of 11, so I leave it alone. And then 2 times 3, there's the 6. And just like that, there's my 2 answers for this problem, my 2 imaginary answers to be exact for this problem. So now you should be able to do number 16 on the other side. So we're going to pause the video so you can work on these, try these on this page, and then number 16 on the next page.